it's like a chicken.
Is it real? That's that
I'm
small?
watching a roadrunner.
Yeah, it's really small.
Alright. So it's not as big as a coyote, you're telling me?
No.
No.
So is the roadrunner big or is the coyote
The
big?
roadrunner-
Look, it's that big.
They're the same size
But
in height.
I'm talking about the cartoon. So did they make the coyote really small or the
Oh.
roadrunner really big?
No, they had to make the roadrunner really big.
So it's
Because
It's a gigantic roadrunner. You're probably scared to meet it.
Based on its surroundings.
Well,
I don't
well,
know.
hold on, let's think about this logically. Baker, what's your guess?
I mean, how is it logical? It's a cartoon in the end.
No, hold on a second. This is smart. If you think about it for a second. Baker, what was your guess?
That
They made the roadrunner
They
big.
made the roadrunner big.
And Justin, we think they made the coyote smaller.
Mm-hmm.
I'm watching it right
I
now.
have to agree with Justin. I think Justin's correct.
What?
Because the coyote pushes around what would seem like very large boulders sometimes. It seems impossible that if the boulder was the same size as the coyote, you'd be able to push it around.
So pushing actually pebble.
Right. Yeah. Maybe. Average growth of a function is nothing more than the average rate of change. We're just using a different terminology, so don't let it confuse you. Average rate of change of a function. It's called growth because it's a growth model, that's all, average rate of change. We know the formula for that already is P of T2 minus P of T1 over T2 minus T1. The same formula you started the whole semester with, right? So that's the same, no big deal. Now, if you'd like to know its instantaneous rate of change, anytime you hear the word instantaneous, that is alluding to the derivative. Instantaneous rate of change. You're still watching that cartoon, are you? Instantaneous rate of change is nothing more than dp dt, right? The first derivative. Right? We'll try one of those problems very quickly. Who's been to Georgia?
Georgia?
Yeah? Yeah?
Isn't your school
More than I
in Georgia?
expected.
What?
That's people in Georgia.
Are you going to school in Georgia?
Yeah.
Is that why you've been there, to like check out the campus?
No, I go to school there now.
What does that say? PT?
Why are you here then?
I live here.
You still pay out-of-state tuition in Georgia?
Yeah.
But you can take classes at PGCC to like transfer over?
Mm-hmm.
Your whole semester is going to be, so what happens in the fall? What do you get in the fall?
I go back to Georgia.
And take only classes there?
Yeah.
Why are you here at all then? You said you live, oh, you said you live here.
Yeah, I live here.
No, but you really live on campus in Georgia.
Yeah.
You just didn't change your, whatever you call it, your residency. You didn't change your residency.
I can't change my residency unless I stay there for a solid year,
That's been a full
change my
year.
driver's license, and declare residency there.
Uh-huh. But you'll probably try to do that
Yeah, I'll do that next semester. I'll do that next year.
All right. Yeah. Oh, that's bad. Out-of-state tuition is bad.
Yeah. I'm trying to get a scholarship. They
What school in Georgia?
Georgia Southern.
I thought you were going to Savannah.
I transferred that. I couldn't pay the HBCU like.
So this is about Georgia. The population in Georgia. Population growth. It's changing rapidly. Justin's going to be a member very soon. So population growth in Georgia. Was that GA?
Yeah.
Right, GA. The population of the state of Georgia in thousands. Pop in thousands. That's a apostrophe S. Population in thousands from 1995, which they are abbreviating, well, not abbreviating, but they're telling this to equal 0, okay? Remember that time, when you're measuring it, is not necessarily a date, and it's rarely a date, right? It's just some moment they've decided upon. So 1995 is times 0 to 2005, which is time t equals 10. So this problem only applies to t greater than or equal to 0, less than or equal to 10. 0 to 10. That's all this polynomial is good for.
Population, what?
Population in thousands. Thousands. The function they give us, which is applicable only for this time period, is negative 0.27t squared plus 101t plus 7,055. So we just need to answer a few questions about the problem. I want to ask you a different question first before they ask theirs. It is, what is the population at time 0? What is the population in 1995?
55.
Fantastic. All right. Determine the average growth rate from 1995 to 2005. Find average. Spell that. Find average growth rate. Find average growth rate from 1995 to 2005. What was the whole way? That's easy. It's just the average rate of change for any function. You do this for any function. So they're calling it growth rate this time, whatever. So we have P of 2005. Is that true?
What?
Should I write P of 2005?
No.
What should I write?
10.
Fantastic. Minus P of 0 over 10 minus 0. Ooh, P of 10. It's not so bad, actually, right? They made it work out very nice. So if you take 10 and you square it, you're going to get 100. 100 times 0.27 is 27. Is that right?
Right.
So we would have negative 27 plus 1010, just multiply by 10, plus the constant 55, minus P of 0, which you said already was 7055. That's why I didn't add them together, because they're going to cancel. There, minus that one. Okay? 10. Cancel. 10 minus 27 is 900 and something or other.
980.
Sounds good. So 983 on 10. 10 is not, no factor of 10 divides 983, so this is our fraction we're stuck with. Now, what do we write for the measurement here? Write for the measurement. What are the units on this thing?
People per year.
There are people. People in thousands. Right.
Over years.
Over years. Perfect. What was the growth rate for Georgia in 1997? So now they want exactly at 1997. They don't want average anymore. Exactly at 97. What was it? So that's going to be our derivative. That's instantaneous. So find the growth rate at 1997. Okay, so you take the first derivative. We need P prime. That's the instantaneous growth rate. And at 97, I guess, is time 2. T equals 2. So we need P prime at 2. There's a notation. So, derivative. The derivative is